James Webb Telescope information about Betelgeuse's blast stunned the industry. Have you at any point gazed toward the night sky and pondered the puzzling dance of the stars? Well, one of the divine entertainers, Betelgeuse, a red supergiant star roost on the shoulder of Orion, has recently taken the spotlight in the cosmic community. In 2019, this brilliant monster stunned researchers with a startling diminishing, alluding to an upcoming inestimable display. Join me on an excursion as we dive into the confounding universe of Betelgeuse, exploring its special attributes, unwinding the science behind its looming cosmic explosion, and uncovering the new discoveries brought to us by the marvel of technology, James Webb Space Telescope. In the heavenly representation in the immense field of the universe, where stars shine like precious stones in the night sky, one specific heavenly substance has caught the attention of space experts and stargazers alike: Betelgeuse. This red supergiant holds the promise of a fabulous cosmic event, the Betelgeuse cosmic explosion. What was once a simple sparkle in the grandiose embroidery transformed into a wellspring of bewilderment when, in 2019, Betelgeuse started to fade, inciting researchers to scrutinize the destiny of this heavenly Goliath. Betelgeuse stands apart as the second most brilliant star in the heavenly body Orion. Its particular ruddy shade and variable conduct make it an intriguing subject for space experts. Despite being the 10th most brilliant star in the night sky, Betelgeuse's exceptional name, meaning the armpit of the giant, adds an air of mystery to its heavenly persona. Arranged at an estimated distance of 430 to 724 light-years from Earth, Betelgeuse isn't just brilliant but also quite possibly one of the closest red supergiants to our planet. With a surface temperature of 3,600 Kelvin, it predominates our Sun, radiating 126,000 times more light and flaunting a size multiple times greater. The live sneak peek high over the eastern skyline, Betelgeuse, the dazzling red supergiant star in the constellation Orion, will evaporate from our view behind an asteroid. An event that rises above the ordinary, an occasion that murmurs the secrets of the universe. Monday, December 11th marks a heavenly gathering, a dance of shadows and light. Betelgeuse, a brilliant presence in the immense span of space, will be occulted by an asteroid named 319 Leona. A couple of moments of enormous discovery will find the stowaway as Betelgeuse's brilliant sparkle is immediately obscured, making a heavenly ring of fire. Yet, this exhibition isn't for everyone's eyes. Just those situated along a restricted way from Asia to Florida and Mexico, via southern Europe, will observe this infinite artful dance. As we consider the rarity of such events, a question arises: how frequently does the universe arrange these ethereal exhibitions, and what secrets could they reveal? Could this divine tango give a brief look into the complex operations of the universe, or is it just a passing recess in the grand orchestra? Betelgeuse's immediate disappearance as the asteroid named Leona floats before it creates an interesting heavenly overshadowing. This transitory display, visible only to those fortunate enough to be along the limited path from Central Asia to parts of Mexico, offers an extraordinary opportunity for researchers to untangle the secrets of Betelgeuse and its unlikely companion, Leona. The dance of light and shadows, Betelgeuse has earned its astronomical prestige for its fluctuating brilliance, a heavenly heartbeat that has kept space experts on the edge of their seats. There's a tendency of strain in the academic community, a murmur that this monster might be near the precarious edge of a fantastic blast. Yet, as our adjustable telescopes dig into the universe, reality arises. Betelgeuse, giving signs of aging, isn't ready to bow out of the inestimable stage right now. As we peer into the endlessness of space, we experience an astounding truth: Betelgeuse is multiple times bigger and thousands of times more brilliant than our natural sun. NASA lays out a striking picture, portraying the star as so epic that it would extend past the orbit of Jupiter if it were to trade places with our sun. Anyway, notwithstanding its astronomical loftiness, Betelgeuse is an infinite youngling, a mere 10 million years old, contrasted with the sun's experienced 4.6 billion years. The ticking clock above Betelgeuse is not just a representation, it's a scientific reality. The rate at which this monster star consumes its grandiose fuel suggests that its days are numbered. It's a heavenly conundrum, a monster that burns brightly but wears out rapidly. Leona's short experience. Now imagine the infinite artful dance set to unfold as Leona makes an uncommon appearance, briefly obscuring Betelgeuse. This heavenly arrangement, visible only to those lucky enough to be along the limited way from Asia to Mexico, is a flashing dance of light and shadows. Stargazers, furnished with their telescopes and cameras, anticipate a 15-second exhibition that vows to uncover more about both Betelgeuse and its elongated friend, Leona, a slowly rotating space rock, settled in the primary asteroid belt between Mars and Jupiter, holds the key to opening mysteries about Betelgeuse's size and the elements of charged gas whirling around the maturing star. The expectation is genuine, with cosmologists uncertain whether Leona will completely darken Betelgeuse, plunging it into all-out obscurity, or if a red-hot line will approach the star in an enrapturing ring of fire. Overshadowing stargazer Januka Massa, organizer behind the Virtual Telescope project, adds a quality of mystery, stating which situation we will see is uncertain, making the event significantly more fascinating. It's a reminder that, in the immensity of the universe, uncertainty rules, and each vast event is a unique chapter in an ever-evolving cosmic adventure. Betelgeuse's extraordinary emission, a vast puzzler, was divulged while we anticipate the divine shroud. We should rewind to a moment of inestimable disturbance, Betelgeuse's extraordinary diminishing in a heavenly scene that challenged assumptions. Betelgeuse shot out a stunning measure of mass, an exhibition 400 billion times more massive than routine solar coronal mass ejections. Our Sun, a natural cosmic neighbor, regularly sheds its outer layers in coronal mass ejections. However, Betelgeuse's emission was a vast oddity, an epic burst that left space experts bewildered. The catapulted mass, probably weighing a few times more than our Moon, moved into space in a showcase of grandiose luxury. The main driver of this extraordinary astronomical light show remains slippery. Researchers estimate that a crest of gas flooding from the inside of the star, helped by Betelgeuse's 400-day throb cycle, may be the guilty party. Yet the vast detective work is far from over, and the specific component behind this amazing scene remains shrouded in mystery. As Betelgeuse recovers from the incredible darkening, researchers turn their gaze toward the star, furnished with instruments like the Hubble Space Telescope. This innovative wonder, capable of looking into the bright domains, gives a close-up perspective on Betelgeuse's environmental layers. The extraordinary darkening, a vast event seen by humanity due to our proximity to Betelgeuse, serves as a sign of the endless secrets prowling in the universe. Into the astronomical obscure, Betelgeuse's future revealed. As the inestimable dust settles around Betelgeuse, questions linger about its future. While the belief persists that Betelgeuse will go supernova, the specific timeline remains unsure. Researchers foresee this inestimable exhibition, a rough blast, marking Betelgeuse's progress into either a supernova or a different fate. Neutron star or a dark opening is reasonable, still, a far-off occasion, roughly 100,000 years away in the astronomical theater. Betelgeuse is both an entertainer and a puzzler, its destiny a cosmic explosion bound to paint the vast material with brightness. It welcomes us to contemplate the secrets of the universe, the divine clock ticks. What's more, as we look at scarab juice from our lawn observatories, we are observers to the infinite, artful dance of creation and annihilation. Hubble's careful focus keeps on investigating Betelgeuse, its bright look unwinding the layers of blue's environment. The star's peculiar conduct, set apart by the extraordinary diminishing and the resulting recuperation, highlights the dynamic and ever-changing nature of the universe in this continuous grandiose adventure. Humankind's investigation of scarab juice remains unconditional, with every perception igniting new inquiries and filling our unquenchable curiosity. The dance of the universe in the tremendous smooth manner. Just about 200 red giant stars exist, and Betelgeuse rules among them. Its titanic aspects expand, its impact a long ways past the domains of our nearby planet group. Assuming Betelgeuse were to supplant our Sun, its span would expand past Jupiter, spelling the engulfment of Earth, Mars, Mercury, and Venus. Insect juice, like all stars, goes through a life cycle set apart by the combination of hydrogen atoms in its center. As it approaches the finish of this enormous journey, it sheds mass unevenly, making a cloud encompassing the star. This cloud, a heavenly work of art, ranges 30 galactic units and is 250 times bigger than insect juice itself. The commencement to calamity, a red star of scarab juice's greatness, loses roughly 1 solar mass every 10,000 years, making way for its inescapable downfall. As the star debilitates its primary fuel, hydrogen, and changes to helium and carbon, burning an outpouring of responses unfurls neon wires with carbon, giving birth to press. The resulting energy discharge triggers a cosmic explosion, a blast, an amazing presentation of nature's strength, fit for surpassing 10 billion suns. The question of the diminishing star, Bug Juice's story, takes an unforeseen turn as it uncovers a confusing viewpoint: sporadic diminishing. In 2019, stargazers and skywatchers saw a blurring bug juice, a peculiarity that endured for months, opposing customary assumptions. Questions emerged: was bug juice passing on, or was this an introduction to its approaching cosmic explosion? As researchers turned their most remarkable telescopes toward ball juice, they were met with proof of an extraordinary darkening. Despite the fact that the star's brilliance eventually got back to business as usual, the star, over 5 billion years of age, entered the later stages of its presence, connoting the potential for a cosmic explosion event. Yet, the specific timing remained slippery, covered in the mystery of Betelgeuse's unique behavior. Disentangling the mystery, broad investigations of ball juice date back to the 1st century BCE, yet the reason for its unexpected and abnormal darkening remains a riddle. Space experts hypothesize that the star's external shell extends and contracts in a cycle, causing vacillations in diameter and normal temperature. The star's throbbing nature, combined with appendage obscuring, contributes to varieties in visual emanations, further complicating the task of translating Bug Juice's secrets. Blue's journey through the universe takes an astounding turn, as it was identified leaping across the interstellar medium at a surprising pace of 30 kilometers per second, catapulted from its home in the Orion OB1 Association, the origin of stars in Orion's belt. Betelgeuse leaves a bow shock traversing more than 4 light-years. Anyway, distances to red, very giant stars, particularly inconsistent ones like Betelgeuse, present challenges in cosmic estimations. The star's genuine width is a moving objective, given its throbbing nature. Appendage obscuring adds a layer of intricacy, changing the variety and force of visual outflows as one gets away from the star's center. The James Webb Space Telescope discovery is a cosmic wonder, ready to reform how we might interpret the universe. Launched into space with a mission to reveal the privileged insights of the universe, the James Webb Telescope turned its look toward scarab juice, bringing forward information that would stun the galactic community. The telescope's high-level abilities permitted researchers to dig deeper into Betelgeuse's secrets. High-resolution imaging, spectroscopy, and multi-frequency perceptions gave exceptional insights into the star's piece, elements, and puzzling diminishing episodes. Unraveling the information as researchers pored over the James Webb Telescope data, another account arose. The telescope's discoveries shed light on the complexities of Betelgeuse's external layers, uncovering unobtrusive changes that indicated the star's approaching change. The discovery started a wave of fervor and speculation, testing existing theories and moving a new rush of inquiry. The prospect of Betelgeuse going supernova brings up a significant issue. What influence, if any, would this grandiose scene have on the planet? While the huge distance to insect juice gives a degree of vast protection, the sheer force of a cosmic explosion can't be disregarded. Conversations follow about possible results, from galactic peculiarities visible on Earth to the impact on our planet's climate. The timing puzzle, the planning of Betelgeuse's cosmic explosion, remains a tricky riddle. Some cosmologists contend that the 2019 darkening episodes might imply the star is moving toward its end, while others propose elective clarifications. The discussion surrounding the timetable of Betelgeuse's disastrous event invites us to consider the endlessness of the universe and the capriciousness of heavenly peculiarities. disclosing Betelgeuse's photospheric puzzle. As we dig into the intricacies of Betelgeuse, we experience the complex dance of its photosphere and circumstellar envelope. The photosphere, a term frequently used to describe a star's visible surface, becomes a stage for material discharged from insect juice, making a stunning presentation of light emanation and assimilation. Anyway, making direct examinations between perceptions becomes a grandiose test, as the star's clear size transforms with the frequency used for estimations. In July 2009, the European Southern Observatory gave an impression into Betelgeuse's infinite theater through pictures caught by the Very Large Telescope Interferometer. A titanic gas tuft extending 30 cosmic units from the star divulged the display of different mass launches from Betelgeuse's environment. Cosmologists found somewhere around 6 circumstellar shells revolving around creepy crawly juice, presenting inquiries concerning the strange mass loss in the last phases of a star's life. A star's staggering orchestra, the elements of creepy crawly juice. The puzzler develops as we investigate creepy crawly juice's long air and its complex elements. Beyond the star's shifting width, the element driving material loss from red supergiants remains covered in secret. These gigantic stars assume an essential role in the enormous recycling of matter that forms worlds. Ongoing headways in interferometric procedures offer a good omen as cosmologists endeavor to disclose the mysteries disguised inside Betelgeuse's barometric dance. In 2019, Hubble and different telescopes identified a huge occasion, a huge surface mass discharge. From BGU, as I said before, not at all like average coronal mass discharges from the Sun, this occasion ousted a stunning 400 billion times more mass. The repercussions were quick, with Betelgeuse going through a fast diminishing in brilliance from October 2019 to mid-February 2020. Anyway, the diminishing occasion took a startling turn, leaving cosmologists baffled as creepy crawly juice's brilliance balanced out. The diminishing showed disentangled scarab juice's secret as the inestimable situation started to get interesting. Cosmologists wrestle with the secret of scarab juice's darkening. Hypotheses arise, highlighting enormous grain circumstellar residue and star spots as potential offenders. In 2022, a study excused dust ingestion, ascribing the darkening to huge star spots. Anyway, a turn in the tale arose in August 2020 when a second residue cloud surfaced, traced back to a chilly region on Betelgeuse's photosphere. The Hubble Space Telescope recommended that this clouding dust came about because of a surface mass discharge, a huge number of kilometers from the star's surface. Material launched out during the cooling process compacted into the star's fading dust. The star's photosphere, a few times more enormous than our moon, divided and floated into space, immediately obstructing Earth's view. The visual exhibition of Betelgeuse's darkening saw even by lawn stargazers in emergency rooms brought up questions about the star's conduct and galactic irregularities. Betelgeuse's unusual lead in the repercussions of its diminishing episode prompted cosmologists to set forth a hypothesis that adds one more layer to the enormous account. Beyond the apparent results, the star's photosphere goes through restoration, displaying increased glow over time. This exceptional conduct comes from the star's interior structure vibrating like a cracked bell, upset by its normal cycle. These discoveries shed light on the maturing system of red stars like Betelgeuse, offering insights into the complex harmony between mass loss and the looming blast as a cosmic explosion. The enormous inconsistency of Betelgeuse's lead and difficulties underscore that a significant mass loss event doesn't necessarily signal an imminent blast. The absence of a large star's surface mass launch adds a component of mystery, pushing stargazers to investigate the unknown regions of heavenly behavior. The telescope's look provides phenomenal bits of insight amidst the divine vulnerability. The James Webb Space Telescope arises as a central participant in unwinding Betelgeuse's enormous show. Its advanced capabilities permit stargazers to detect recognizable surface features, giving constant perceptions of peculiarities previously inconspicuous. This includes the launch of materials from creepy crawly juice with infrared radiation while heading to be distinguished by the James Webb Space Telescope. As we contemplate the ramifications of these uncommon experiences, It becomes apparent that the cooperation between ground-based telescopes like the VTI and space telescopes like Hubble and James Webb is fundamental for grasping the perplexing woven artwork of the universe. Every discovery adds a string to the vast story, pushing the limits of our understanding. Betelgeuse's reprise from darkening to brilliant resurgence makes the vast adventure go off in a strange direction. As Betelgeuse's darkening event comes to an end, it stands ready to recover its position as the 10th most brilliant star in the night sky. Notwithstanding its massive distance, BJU sparkles nearly multiple times more brilliant than the Sun, displaying the enormous energy demands required to support its iridescence. The new discoveries prompt a critical inquiry. Could Betelgeuse's vibe of darkening be a prelude to an impending blast, or is it only a stop in the star's heavenly ensemble? Stargazers wrestle with the complexities of Betelgeuse's behavior, recognizing that the power of the blast is reflected in the harm observed. The cosmic explosion would display a divine show for Earth, the enticing possibility of Betelgeuse's potential cosmic explosion. The blast allures us to consider the enormous exhibition it would release when the star depletes its fuel and capitulates to gravitational breakdown. A cosmic explosion will enlighten the night sky for a range of weeks to months. Betelgeuse could rival the splendor of a full moon, projecting its brilliance across the infinite stage. As we speculate on this divine show, a principal question waits. When will this remarkable situation transpire? The unconventionality of infinite peculiarities challenges our presumptions, leaving us to keep wondering whether we will witness Betelgeuse's grand finale in the course of our lives or if it stays a cosmic event destined for the far-off future. Earth's destiny, shaped by Betelgeuse's astronomical show, holds a comforting note. In spite of Betelgeuse's potential blast, its enormous distance guarantees that Earth remains safe. Space experts state that the safest distance from a cosmic explosion for human life is 50 light-years, making Betelgeuse more than 10 times farther. As opposed to facing annihilation, Earth's denizens are in for a heavenly scene, a brilliant star suddenly gracing the night sky. As we explore the enormous odyssey of Betelgeuse, from its throbbing photosphere to the possibility of a cosmic explosion blast, the James Webb Space Telescope remains as a reference point, enlightening the neglected domains of the universe. The tale of Betelgeuse is an indication of the enduring mysteries that coax us to investigate, question, and wonder about the miracles of the universe. Share your thoughts, conjecture on the grandiose questions, and join us in this exciting journey through the universe. If you're as fascinated as we are by the discoveries delivered by the James Webb Telescope, be sure to subscribe to our channel and hit the notification bell. We'll dive deep into the data, disentangling the secrets hidden inside Betelgeuse's grandiose dance. Join us in this exploration of the universe, where every discovery opens a new chapter in the narrative of our astronomical existence. Don't miss out on the latest updates and in-depth investigations. Subscribe now and become part of our vast community. Together, we will continue to unravel the mysteries of the universe and embark on a journey of discovery that transcends the limits of our imagination. Subscribe now, and let the vast investigation begin.